Hello and welcome to Math with Mrs. Becker. Today in calculus, we are going to look at some rules for differentiation. Chapter 1, Section 6 covers the constant multiple rule, the sum rule, and the general power rule. So the first rule we are going to look at is called the constant multiple rule. And what this means is if you have a constant in front of a function. So for example, if I look at example A, I have 5 times x to the power of 4. 5 is a constant. It is just a number. My function is x to the power of 4. So one rule, you are allowed to take that constant out front. So for example here, I can take 5, then I can find the derivative with respect to x of x to the power of 4. So that's what the constant rule means. If you have a constant, in our case, most of the time it will be a coefficient. I can take that value out front, then find the derivative of the other piece. So it would be 5 times the derivative of x to the power of 4. You bring the 4 out front, you keep the x. This was an exponent of 4. If I reduce it, now it's a 3. Now you go ahead and multiply the 5. 5 times 4 is 20x cubed. So that is a rule that you can use. Let's go ahead and try another one. 5 is a constant, so I can take 5 times the derivative of the square root of x. Going a step further, 5 times the derivative of the square root of x is x to the 1/2 power. Going a step further, 5 times, now I can calculate that derivative. I bring the 1/2 out front. I keep the x, reduce the exponent by 1. 1/2 minus 1 is negative 1/2. So now when I multiply this, top times top, bottom times bottom, this 5 doesn't have a denominator, so it's like it has a 1. This is 5/2. X goes on the bottom because it's a negative exponent to the 1/2, so it's a square root of x. This is my final answer, so I cannot leave a square root on the bottom. So I need to rationalize by multiplying both top and bottom by that square root of x. So 5 square roots of x over 2x. Okay, let's look at one more. Remember, if you have a number over a variable, I can go ahead and take that out as 3 because check this out. Negative 3 times 1 over x would be negative 3 over x. So this negative 3 is a constant. They just simplified it, multiplied them together to get this. So I can go in reverse and I can go ahead and take that negative 3 out. Then I'm finding the derivative of 1 over x. Now remember, if I have negative 3 and I'm finding the derivative of 1 over x, if x is on the bottom, it really has an exponent of negative 1. So it's negative 3 times, now go ahead and find the derivative. Take the negative 1 out front, x, reduce the exponent by 1. Negative 1 minus 1 more is a negative 2. Multiply, covered up that 1. Negative 3 times a negative 1 is 3. X has a power of 2 on the bottom because it's negative. So those are some examples of what the constant multiple rule is. Okay, now the sum rule, we have actually been doing this quite a bit. They just didn't give us a name for it yet. So this tells us that if we have more than one term that we are finding the derivative of, whether it be adding or subtracting, what you do is you just find the derivative of each individual term. That's what that means. So if I want to find this derivative, 7 times 2 is 14. I still have an x. I had 7. When you minus 1, it's down to 6. Minus, bring the 5 out front. You still have an x. My exponent was a 5. I reduce it, so now it's down to 4. The derivative of a constant is 0, so my derivative is 14x to the power 6 minus 5x to the power 4. So it's just finding a derivative piece by piece. Let's do another one. If I want to find the derivative of x cubed plus 5x, you bring the 3 out front, I still have the x. My exponent was 3. If I reduce 1, I'm down to 2. Plus, this is an unwritten 1. 1 times 5 is 5. There was 1x, so when I reduce it, it's gone. So 3x squared plus 5. The next one, I do want to go ahead and set up because I have my exponent on the bottom. So this is x to the power of 4 minus 3, x to the negative power of 2. This was an x squared on the bottom, so when I bring it up, it's a negative 2. Now you find the derivative of each piece. Bring the 4 out front. Keep the x, reduce the exponent by 1. Negative 2 times a negative 3 is positive 6. Keep the x, reduce the exponent by 1. Now it's a negative 3. So my final answer would be 4x cubed plus 6 over x cubed. So that's what the sum rule is. If you have more than one term, whether they're being added or subtracted, because remember, subtraction by definition is addition of the opposite. So even when you're subtracting, it still follows the rules of addition. So sum rule, you just find each derivative one piece at a time. Okay, now general power rule. We've looked at what to do if you have a term with an exponent. But what happens if that exponent is on a group? So on a binomial or on a trinomial. That's when you use what's called the general power rule. So what happens if you have an exponent on a group? The exponent comes out front. You rewrite the function exactly how it is. Don't change anything. The exponent is reduced by 1. Then you multiply it by the derivative of whatever was in the parentheses. Okay, so let's look at 1. This 2 goes to the group 3x minus 2. So the 2 comes out front. You keep the group the same. Reduce the exponent, so now it's a 1, times, now you find the derivative of the inside. Well, this is a linear term, so the derivative of the inside is a 3. Now, sometimes you could go ahead and simplify. Okay, this one I can simplify pretty darn easily because I have nice numbers to deal with. This is a 1, so it's really like 2 times 3x minus 2 times 3. So I could go ahead and distribute. So I would have 6x minus 4 times 3. So I could go ahead and distribute there. So I'd have 18x minus 12. Okay, so that one works out pretty nice. We will end up with some exponents where it's crazy. And when you have super crazy exponents, I'm not going to make you expand it. Right here, if you understand this, you're good for the general power rule. Obviously, if they're easy to simplify, go for it. But if it's an exponent beyond 2, I say just leave it how it is, okay? So if I'm doing the general power rule here, I'm going to grab a separate sheet of paper just to make sure I have some room. So the 3 comes out front. That 3 was on the group 2x squared minus 3x plus 5. So I keep the group the same. Reduce the exponent times, now you have to multiply it by the derivative of the inside. Well, this would be 4x minus 3. So if you kept it here, 3 times 2x squared minus 3x plus 5 to the power of 2 times the group 4x minus 3, I am totally fine with that. I will tell you that sometimes in the back of the book, what they do, just so if you're checking your answers, they would take this 3 and this 4x minus 3 and say, okay, well, that's 12x minus 9 times 2x squared minus 3x plus 5 to the power of 2. Okay, I just want to show you those little things. So if you are working out of the textbook and checking the back of the book, sometimes they'll leave it like this. Oftentimes they will combine those. And I just want you to see where they're getting those answers, so that way you can go ahead and check your solutions and make sure you're on the right track. Okay, if I have 1 minus x squared underneath a square root, that is the same thing as 1 minus x squared to the 1/2 power. That 1/2 goes to both of these terms because both of these terms were underneath the radical. So when I find the derivative, it's the general power rule. Bring 1/2 out front. Keep the parentheses the same. Reduce the exponent by 1. Multiply by the derivative of whatever was on the inside. This is a 0. This would be a negative 2x. I'm going to go ahead and multiply this by this because it's just one term by one term. 1/2 of a negative 2x, well, that's just a negative x. This is negative, so it goes on the bottom. So I have a square root of 1 minus x squared on the bottom. Yeah, we can't do that, guys. So what I have to do is rationalize the denominator times 1 minus x squared. So your final answer is negative x times the square root of 1 minus x squared over. Now remember, when you multiply radicals, I would have 2 of these, so it would be this exact thing squared, so it would be 1 minus x squared on the bottom. Okay, so that one was a little crazy. Now what they're going to go ahead now and have us do, we just learned 3 new rules for finding differentiation or finding your derivatives. There are times where you'll be given a function and it's going to take more than one rule to do this. So that's what we're going to go ahead now and look at. If I have 5 times the cubic root of 1 plus x cubed, I'm going to use the general power rule and the constant multiple rule. So I'm going to take that 5 out front. Then I'm going to find the derivative of 1 plus x cubed. Cubic root means I have it to the power of 1/3. So my 5 stays out front. General power, bring the 1/3 out front. Keep the group the same. Reduce the exponent by 1. So if I'm minusing by 1, keep in mind that I'm minusing 3 over 3 because that's the same value as 1. So my denominator is a 3. 1 minus 3 is -2. Now I have to multiply by the derivative of what's on the inside. The derivative of x cubed is 3x squared. Kind of wild, but we can do this, guys. Okay, if I go ahead and I multiply 1/3 by 3x squared. So I'm still just working on the inside. I have that darn 5 on the outside. 1/3 cancels a 3. So I have x squared on the top. This is a cubic root because it has a 3 on the bottom. This is 1 plus x cubed to the power of 2. Okay, so at this point, I can go ahead and multiply that 5 in. Top times top, bottom times bottom. So at this point, I have 5x squared over the cubic root of 1 plus x cubed squared. Well, I cannot have a cubic root on the bottom. In order to cancel a cubic root, I need 3 of these. Right now, I have 2. So I need to multiply top and bottom by a cubic root. I need 1 additional 1 plus x cubed. So here is your final answer. 5x squared times the cubic root of 1 plus x cubed over. I have 3 of these, 2 here and 1 here. So the cube would cancel the cubic root, leaving me 1 plus x cubed. That is your derivative. Okay, now looking at the stuff, isn't it crazy? Like, that is a wild answer. But if you just take it one step at a time, it's not so bad. Let's keep on going. Here's another one where in order to find the derivative, this is going to take a little bit of time and a couple different processes. If I have -2 over 4x plus 3, first off, you need to realize that this is on the bottom, and it's both terms on the bottom. So this is really -2, 4x plus 3 to the negative first power, because the negative is what would put this on the bottom in the first place. So again, I'm going to do the constant multiple rule. I'm going to take that -2 and not worry about it till the end. That's what that rule allows us to do. Now this is general power rule because I have an exponent outside of a set of parentheses. The -1 comes out front. 4x plus 3 stays the same. Reduce the exponent by 1, making it a -2, times the derivative of the inside. This is a linear function. The derivative of 4x is 4. The derivative of a 3 is 0. I can multiply those two values together. So I have -2 out front. -1 times 4 is -4. 4x plus 3 to the negative power of 2. Last step. -2 times a -4 is a +8. This negative goes to my 4x plus 3, and it has a power of 2. And we're done. So that was general power rule and the constant multiple rule. We are halfway done with the notes. Okay. We do definitely want to make sure that anytime we learn a new skill, that we don't lose the skills that we've already learned, if that makes sense. Okay, so we've talked about derivatives, but let's take it all the way back to the beginning. Tangent line. A tangent line is a line that touches a curve at one point. Okay, if you want to find the equation of a line, any line, okay, so in this case it's a tangent line, but any line, you need 2 things. You need a slope and you need a point. So let's go ahead and do this. If I want to find the tangent line to this curve, The formula to find the slope is called the derivative. So if I want to find a slope, I need to find the derivative of the function. 2 times negative 2 is negative 4. I had 2 x's. I take one out, I'm down to 1. Plus the derivative of 6x is 6. The derivative of 5 is 0. So this is the derivative. This is the formula to find the slope based off of x. So if I want to know the slope, I need to fill in the x value, which is negative 2. Negative 4 times negative 2 is positive 8 plus 6. The slope is 14. Now, if I want to find the point, we know x. X is negative 2. To find y, this is y equals. You just have to plug x into the original. So it's negative 2 times negative 2 squared plus 6 times negative 2 plus 5. That's what the y value is going to be. So negative 2, plug in a negative 2 squared plus 6 times negative 2 plus 5. I have negative 15. So this is my ordered pair. Now, if I want the equation of a line, I have a point and I have a slope. So point-slope form, y minus the y value from the ordered pair, negative 15, equals m, 14, x minus the x value from the ordered pair, negative 2. Minus a negative becomes a plus. Here as well, minus a negative becomes a plus. Now what I need to do is get y all by itself. So step 1, distribute. Y plus 15 equals 14 times x is 14x, plus 14 times 2 is 28, minus 15. So y equals 14x, 28 minus 15 is 13. There's the equation of the tangent line to the graph negative 2x squared plus 6x plus 5 if your x value is a negative 2. Okay, here is another one. Now this one's wild, you guys. Okay, find the slope. They only want the slope. Well, what we need to do then is find the derivative of the function and fill in the x value. This is the sum rule because I do have separate parts, but check this out. This is also going to be the general power rule because I have a square root over 1 minus x. That means I have the group 1 minus x to the power of 1/2. So if I am finding the derivative, take the 10 out front. So it's 10x to the power of 9. I got that piece. The derivative of a 1 is 0 because it's a constant. Plus, bring the 1/2 out front times the original, 1 minus x. Reduce the exponent by 1, so it's negative 1/2, times the derivative of the inside, which would be negative 1. So if I go ahead and I simplify this, 10x to the power of 9, positive 1/2 times a negative 1 is negative 1/2. This would be on the bottom, square root of 1 minus x, because it's a 1/2, it's negative, it goes on the bottom. Here is your derivative. Now, we do not have to rationalize the denominator because it's not saying find the derivative. So this is not my answer. If it was asking for the derivative, yes, you'd have to rationalize the denominator. It's asking for the slope. So our final answer is what we get when we take our derivative and change the x's to a 0. So 10 times 0 to the power of 9 minus 1 over 2 times the square root of 1 minus 0. Well, 0 to the power of 9 is 0. 0 times 10 is 0. So I have negative 1 over 1 minus 0 is 1. The square root of 1 is 1. 1 times 2 is 2. So your answer, the slope, is negative 1/2. So this graph, if you were to graph it, if you look where the x value is 0, it's the slope of the tangent line is going down 1 over 2, down 1 over 2. Okay, well, let's look at another one. The tangent line, we want to find the tangent line to this curve, has a slope of 2 at 2 points. Find those 2 points. Okay, so again, what we need to remember is that the slope is based off of the derivative. So step 1, I need to find the derivative. X cubed is 3x squared. 2 times negative 6 is negative 12x. Negative 34x, this would have a 1. 1 times negative 34 is negative 34. I would no longer have any x's. The derivative of the original, or the derivative of the constant, negative 9 is 0. So here's the derivative. it says the tangent line to the curve of this function has a slope of 2 at 2 points. So we're going to set the derivative because this is the formula for the slope. They're saying that there are 2 points. It says it has a slope of 2 at 2 points. So that means this derivative equals 2. The formula for the slope is 2. If I go ahead and I minus 2, 3x squared minus 12x minus 36 equals 0. Right away, I notice I can divide everything by 3. X squared minus 4x minus 12 equals 0. I just divided by 3. 3 divided by 3 is 1. Negative 12 divided by 3 is negative 4. Negative 36 divided by 3 is negative 12. Now I can factor two numbers that multiply to negative 12 and the same two numbers add to a negative 4. Well, that's negative 6 and 2. So this is x minus 6, x plus 2 equals 0. So my x values, if I go ahead and add the 6 over, x would be a 6. Here, I'd have to minus the 2 over, so x would equal negative 2. Okay? It says find those 2 points. Right now, we have the x's. If I want to know the points, you have to find the y value. My x's are 6 and negative 2. To find the y value, you have to put it into the original. So if I take 6 and I put it into the original, 6 to the power of 3 minus 6 times 6 squared minus 34 times 6 minus 9. When I put in a 6, I have negative 213. If I go ahead and I put in a negative 2, negative 2 times the power of 3 minus 6 times negative 2 squared minus 34 times negative 2 minus 9 is 27. So these are the 2 points on the tangent line to this curve where if you look, the slope would be up 2 over 1, up 2 over 1. So again, a lot of this is making sure that you totally read the instructions. If it says points, you need both the x and the y. If you would have stopped here, that would have been a bummer because you would have only found the x values, not the full points. Okay, the derivative as a rate of change. So one thing here is just connecting. Remember back way in Algebra 1 and maybe even 8th grade math, when you talked about slope. Slope is the rate of change, okay? How steep a line is. You're looking at the speed that something is changing. They want you to realize that because the derivative is dealing with a slope, often they will be asking you to find the rate of change. Okay, so again, the derivative is your formula for the rate of change. So when you are doing story problems, if they want to know the rate at which something changed, you have to figure out the slope. Okay, example 6. Declining sales. At the end of the holiday season, the sales at a department store are expected to fall. It is estimated that for the X day of January, this is what the sales will be, and it's in thousands of dollars. So if you are computing our function with a 2, that means you're just putting a 2 in here right now. And what you're calculating is what the sales will be for the X day of January. Well, this one means on January 2nd. Okay, so interpret your results. This would be sales on January 2nd. If I just go ahead and fill in a 2. So 3 plus 9 over 2 plus 1 squared. So 3 plus 2 plus 1 is 3. 3 squared is 9. 9 divided by 9 is 1. 3 plus 1 is 4. So sales January 2nd are expected to be $4,000. Now, if you want to find the rate of change, meaning are the sales dropping, meaning you have a negative slope, are the sales increasing, and at what rate, you have to find the derivative. So this is 3 plus 9 times x plus 1 to the negative power of 2. I need to find the derivative of this. Well, the derivative of a 3 is 0. Bring out that negative 2. So negative 2 times 9 is negative 18. This is general power rule. okay, because this is more than one term. So I brought the -2, multiplied it by the 9 that's already there. I keep x plus 1 the same, reduce the exponent, multiply it by the derivative of the inside, which happens to be a 1. So my derivative is -18 over x plus 1 to the power of 3, because 1 times -18 kept this as a -18, negative exponent brought this to the bottom. Now what they want me to do is go ahead and calculate the rate of change, meaning use the slope. So -18 over 2 plus 1 to the power of 3. So it's -18, 2 plus 1 is 3, 3 to the power of 3 is 27. So -18 divided by 27 is -2/3. Okay, so what I could actually do there is just divide by 9. So the slope is -2/3, so it's negative. That means that the sales are dropping, okay? So you are interpreting your results. If you're putting in the slope, if this would have been a positive, that means your sales are increasing. But on January 2nd, the sales are 4,000, and at that time, we are experiencing a decrease in sales, okay? Let's look at another one. Predicting sales. Refer to the example above. Use the values. Hey, we got that. Okay, so use the values S of 2 equals 4. And when we put in the derivative, we have that -2/3 to estimate the sales on January 3rd. Compare your results with the exact value of sales on January 3rd by computing S of 3. So what they want you to do is go ahead and figure out what your sales would be on January 3rd. What this is telling us is how much we're dropping per day. So if we had $4,000, okay, so let's go ahead and just use our derivative first. If the sales on January 2nd were $4,000, what we can expect is that they are going to drop 0.667%, so $66.7. Okay, that's what they would do the next day. Now what this is saying, oh, no, sorry, my bad. This is in thousands. Okay, because remember we're doing thousands of dollars, so I would go tenths, hundredths, thousands. So this means that I would have to subtract $667. Okay, my bad, sorry, it wasn't a percentage. So I started with 4,000. That was the sales on January 2nd. The derivative, this is dropping 0.667. It's thousands. So I have to move the decimal, tens, hundreds, thousands. So that means I'm losing $667. So making an estimation, I'm saying that the sales on January 3rd are going to be down to about 3,333. Now they want you to go ahead and calculate. Put 3 into the original function. So S of 3, 3 plus 9 over 3 plus 1 squared. 3 plus 9 over 3 plus 1 is 4. 4 squared is 16. So if I have 3 plus 9 divided by 16, I have 3.5625 thousandths. 1, 2, 3. So it's approximately, or actually this would be the sales, 3,562.5. And so what they want to show you, yeah, obviously it's not exact, but for a quick estimate, you could figure out your slope and say, oh, drop the sales by that. We're still within a couple hundred. Okay, so just 2 ways that you can make predictions. Okay, so here's your assignment. I'm going to have you try a bunch. Most of them are going to be practicing the new derivative rules, the constant multiple rule, that general power rule, the sum rule. You will see some tangent lines because it is really important to connect what we are learning now to things that we have already learned. Hope you had a great day, and I'll talk to you soon.